We are working with Keysight on a number of interesting things, and that's what I'm going to talk about today. So we have a concept that we have been developing in some sense in partnership with the government to create the notion of secure IP repositories. So from Microsoft's perspective, and if you do attend, if you go to one more presentation, you should go to a Microsoft presentation. I actually have no idea if there any more are scheduled, but nonetheless. So we have a cloud-based platform, and this cloud-based platform basically allows you to design and collaborate on the cloud in a way that's like indistinguishable from desktop, but obviously employing power of cloud-based collaboration and essentially turning cloud into really productive environment for collaboration among individuals, groups, companies, entities, and so on. And so we have the base platform, but we're also building up the next layer of capabilities to make Azure Cloud even more suitable for design of chips. And so one of the boxes that we're working on is trusted design assets, and this is where the intersection of interests with Keysight comes in. So the focus on the IP is justified in an obvious way. You know, IPs are basic building blocks, most of the SOCs, 90% third-party IP content. They come from multiple sources. They can be custom, they can be purchased, repurposed, crowdsourced. However, it's really hard to confirm that they're viable. Confirming functionality of the IP is really hard. You can only do it through simulation and some other verification methods. And you can never get a question answered like, so you can analyze to assess what does this IP do. But you can't ask the question, what else does it do? Does it do something outside of what it's purported to be? In short, is it secure? And so this is particularly important because provenance of IP is highly variable. It can come from a variety of sources, and you really don't know who touched it along the way. And that makes it an ideal host for hardware Trojans. And and of course, there are unpublished capabilities, intentional or unintentional, that also represent vulnerabilities. And so what we found is that whenever people touch a third-party IP for the first time, they're not comfortable with it. And they have to go through rigorous, improvised process of developing comfort with the IP. And even then, I think third-party IP really can't truly be trusted because provenance is unknown. So the challenge that we wanted to take a look at is how can we establish trust in IP out of the box? And so the approach that's considered is to basically incorporate IP reuse capabilities into the cloud service that supports all tools and methodologies, doesn't interfere with the existing design flows, and utilize advances in hardware security over the last 12 to 15 years to actually assess vulnerability of the IP. So when I was introduced, they did mention that I served 2 terms at DARPA, and at DARPA I was responsible for hardware security as one of my portfolios. And so I was fortunate enough to get exposed to a massive community of security researchers that have been making significant progress in this area, which is looking for vulnerabilities in IP. And so we also wanted to capitalize on enterprise scale and technical assets that, for instance, Microsoft possesses, like our cloud platform, like the fact that Microsoft has GitHub and data governance capabilities. And we're working in concert with some government agencies because the problem I just described is not just in the commercial realm, but also in defense applications. So, you know, artists' concept here might look like this. A designer, through a cockpit, interacts with IP repositories and engages in discovery, IP management, collaboration. These IP repositories can come from multiple sources. They can be in-house. They can be constructed by external entity, and an assembly of IP libraries could exist along a particular domain or application space or whatever. So what we are looking at providing on the cloud is a set of this services where we can do vulnerability analysis on a piece of IP. And that includes static, dynamic, and formal methods being applied to the IP to observe what the vulnerabilities are. There can be also vulnerability mitigation capabilities and injection of countermeasures. So there are IP countermeasures like obfuscation, side channel protection, watermarking, and so on. And all of that can be combined with provenance management, and this, of course, is where Keysight strengths come from, because they already have infrastructure for IP discovery, IP management, IP reuse, and it fits very nicely into this vision. And so the idea here is that you would start with a piece of RTL that comes with metadata and a test bench, which is classical packaging of the IP. And on the way into the repository, you would subject it to a series of checks, like, for example, formal check, static check, dynamic check, and then as a result, you would arrive at a trust score, which is some kind of quantified numeric representation of what is the degree of trust that is possible here. That can be converted into electronic watermark, which is then injected back into the piece of IP. Electronic watermark is additional state machines that are incorporated into the design in such a way that it's like impossible or very difficult to detach them. And if you detach them, it breaks the design. So it essentially incorporates the watermark into this. And then you could have an optional human in this loop who would look and attest whether this trust score makes sense or not. And ultimately, this gets deposited in the IP repository, now bundled with all the stuff that was watermarks and whatever that was injected, modified metadata, and then, of course, we make an entry into the traceability management thing. And this is where Keysight comprehensive design data and IP management capabilities come into play. Thank you, Keysight. Obviously, Keysight has integration with EDA flows, tools for issue tracking, integration with document management, but most importantly, traceability really is important, because we want to establish provenance. Where has it been? Who touched it? Why did they touch it? What did they do to it? And so on. And so, so basically, this is a platform where we are working on at Microsoft, and this yellow layer is the capabilities that we are going to add, if you will, to the MSWB platform, which we have recently announced and are showing here in the show. And we believe this type of approach is applicable not just to chips, but to other vertical markets, not just silicon, but systems, mechanical, aerospace, automotive, and even civil engineering. Thank you for listening, and please use Keysight products.